Okay, so today I was going to review problem number one. That is a coding problem for Physics 2. The problem states that the program below calculates and displays the net electric field at 8 equally spaced locations on a circle surrounding an electron. All of the observation locations are in the XZ plane, a distance 10 centimeters from the electron. Please fill the missing pieces of code with your own work. So I highlighted parts that I feel were really important and crucial to understand in this problem. There are 8 equally spaced locations. Each of these is going to be considered one of the observation locations. And we know that it's in the XZ plane, so we shouldn't be calculating for something that's in the Y. And if we do, then there might be something wrong with your code. 10 centimeters from the electron just means that this is the distance away from the source. So we move over here to our actual glow script code. We of course have our constants given to us. We have the 9 times 10 to the ninth for Coulomb's constant. We have our electron known charge. And then we have our Q value, which gives us the position of the sphere, color, radius, and charge. We're also given theta and d theta. Theta and d theta are just basically letting you know what the actual observations are going to change from one point to another in those 8 equally spaced. So first step is to calculate an obsculation vector. Obsculation is basically another word for observation point, and since we know that our observation point is 10 centimeters away from that original source location of the charge, we can just add that on to the charge position. So q dot post, that calls back to our q here and calls to its position vector, and then add that to 10 times the vector of cosine of theta times sine of theta. This cosine of theta and sine theta just recall back to your angle, whichever point you may be in the circle. Just to give a visual, we could say that we have an electron right here, and then we have this little outer ring with all our points approximately 10 centimeters away. So we have 1, 2, 3, 4, 5, 6, 7, 8. Each of which 8 centimeters away, but at different angles. So then, after we calculate our obsculation vector, which we now did using this, remember that y, it's not in the y plane, so you should have a 0 there. We want to find E net. To find E net, we must first find our R, which is always going to be our position of observation minus our source. So let me go ahead and choose red here. So for our actual position, we know that we know first our observation location is just obsculation, which we found before, minus the sphere dot position, because that's where your charge is coming from. That's the source. Now R mag, it's just a variable we're setting to find the magnitude of our R vector, which we need in the formula to actually find E net. So now as you can see, it's just a simple mag of R. Now if I try to find R norm, it's just once again another command that you must know. Very useful for later problems. So norm of R. And now you just use your point charge formula, or your relative formula that may be used. You may have a disk, you may have a rod. There are plenty of different things, but since we have a circle here and the charge is being caused by a point charge, we can just use our constant K. So as we can see, we're using K times negative E, because we know it's an electron, so it's going to be that charge but negative, times R norm divided by R mag squared. Well, that's basically just the point charge formula, which if you didn't know by now, you should be able to know, because it's a vital part to most of your beginning of Physics 2. So now create an arrow to display E net at obsculation. when we're creating an arrow, we want to make sure we think about what position is it starting from. So starting at obsculation. So that's a pretty easy step right there. All we want to do is make sure that we don't mess up any of our coding. Keeping track of all your pieces of information is probably one of the most important things I've learned. So obsculation. And then our axis. Our axis is actually going to be our enet. Especially because it does not ask for a scale factor. We do not have one. We want to make sure that our axis is somewhat equal to what we need in our problem. So that's when it usually asks for axis, it's usually going to be set to your enet. And then calculate the new value of theta. So theta is just that angle that we were looking for. If we go back to our image, theta is just going to be like that change. So maybe we're here, and then we're going to go over here, and then it's just going to keep changing. We know theta starts at 0, and d theta is just a calculation from one point to another. And using that knowledge, we can just say that this theta is equal to theta plus d theta. Because this just means you're changing to the next observation location and then taking the measurement again from there. And the cycle will keep repeating since it's in the while loop. Well, this is a basic way to go through the coding, and one of the ones that I struggled with just because I made a few simple sign errors or didn't know how to set up the location. I just want you to keep in mind, definitely make sure you take into account the information given in the problem. I thought that the 8 points that were equally spaced would change the formula, but that wasn't true. All it just changed was your observation location, where each one was treated as a point charge.